Hi everybody, in this video we will be discussing about how to destroy a linked list. It is important that always whenever we get a memory dynamically allocated, we have to give back the memory properly after usage. So let us consider a linked list, circular linked list like this, and we want to destroy this. Logically how it will look like is, if there are 5 nodes it will look like this, and we have to remove the first node. After that it should look like this with 4 nodes. After removing again the first node, it should have 3 nodes like this, 2 nodes, 1 node, and at last head should become null. But the point here is, if we want to have the same kind of implementation, each and every time I have to go to the end and I have to change the address of the head. But this is the point where the list is going to destroy itself, right? So it is not required that we have to maintain the address of the first node in the last node. So what I am going to do is, I am just going to make the linked list as a single linked list, normal single linked list without the circular property. So what I do is, I initialize the temp to head, and I move the temp to the last node and make the next part of the node as null. And while head is not equal to null, we are going to do the same thing what we did in single linked list. We will make a temporary pointer, we will initialize that to head, we will move head to the next node, delete temp. This we will be repeating till we reach the last node. We will come out, and for the last node we will be doing this, delete the temp node and make the head as null. So let's do the implementation as C. So do the declaration first. So I have to move to the last node. And I have to make the next part as null. This loop will take me to the last node, and here I have to tell temp next equal to head, equal to null. So this is C language, so I have to put L and then the dereferencing operator to access the head. Okay, and while head next is not equal to null, right? We are going to do this for all nodes except the last node. So let us tell while temp next not equal to head next not equal to null. We have to do, but before that I have to make once again temp equal to head, L head. Okay, and L head next not equal to null. I should be making temp equal to head, and I will make head to move head to the next node. So let's tell temp equal to L head. Okay, and I'll be moving head to the next node. So tell L head equal to L head next. This is the way to make it. And delete temp. We have to make this, and after coming outside we have to delete the last node. So let's tell delete temp, and we have to make head as null, head equal to null. Okay, so I have invoked this function here also. Yeah, wherever we use head we have to use L head. Let's compile the code and check. Yeah, so too few arguments it is telling. So in the place where I have called in the application file, I have to pass the list, right? Address of the list. Okay, but I'm getting core dump, so some mistake in the deletion. Let's check the code. So the mistake is here. I have initialized temp, and once again I have made this temp equal to L head here. Instead, what I should do is, and what is happening is actually I reach the last node and I am trying to delete the node which I have already deleted. That is the problem, because you see the last line of this loop is delete temp, and outside the loop also I am telling delete temp. Actually temp is having the address of last but one node, right? So I should make this temp equal to L head come before I do the deletion, right? This is the change that is required. Let us compile the code and check it now. Compile it and run it. It's running fine, and also you can see that it is printing 1, indicating that the list has become empty. You can see here in the main I have called the destroy list function, and then I am once again checking whether the list is empty. Yes, the list is empty. Okay, thank you.